Hi, I'm
everybody and good
Morning.
two. Dear
friend and
Lecturer,
Mr. Salihin.
today
we
going
two
present,
About
Hart
communication
we,
hope
you
all.
will enjoy
and
learn
while
Watching
the
video
before
we
start
our
presentation. Let
me
introduce
our
group.
members. Hi, I'm Kalai.
I'm Karthik.
hi everyone, I'm Sugan
I am Murali.
Hi, I'm Ram.
and I am Kumar. Let's go.
Hi everybody, welcome to the School of Hogwarts.
Today we're going to learn about new things. You know what I mean? Yeah, it's probably new. Probably you never heard it before.
And today we are going to learn about Hart devices.
Oh, nice.
Calm down. Okay, bro. 3. HART stands for Highway Addressable Remote Transducer. For simple understanding, it's a hybrid communication protocol that uses Bell 202 frequency shift FST technique to improvise digital communication signals as a top of an analog 4.20 mA current top loop signal.
I don't understand any of that. Please bring the picture up.
Process measurement is the collection of information from various types of sensors. They monitor, control, and diagnose the status of a piece of equipment or production process. A transmitter or transducer device converts the physical properties to an electrical signal for inclusion into a process control system. The 4 to 20 milliamp signal was adopted because of its high immunity to electromagnetic interference, its reliability over long cable runs, and its low power consumption. Today, the most widely used electrical signal in process automation remains the 4 to 20 milliamp signal. When a transducer measures a value like temperature, it's converted to an electrical signal proportional to that temperature. If the transducer is measuring the temperature of a tank of liquid, which normally ranges from 0 to 100 degrees Celsius, it will output a 4 milliamp signal when the temperature is 0 degrees and 20 milliamps if the temperature is 100 degrees. A signal less than 4 milliamps is commonly used to indicate a fault condition, such as a wire or sensor break, while a signal higher than 20 milliamps indicates an overrange condition. The Hart protocol uses Bell 202 frequency shift keying to superimpose digital communication signals at a low level on top of the 4 to 20 milliamp signal.
This is the normal example of landline phone. We're going to show you how does this work, then we'll compare with the Hart devices so you will have an understanding.
Hello,
Hi, hello.
is this Kalai?
Yeah, it's me, Kalai. Is this Ram?
Yeah, I'm Ram. How are you?
I am good, Ram. I am calling from Kluang.
Oh, okay. I need you to attend to class today because you have very lack of attendance.
Oh, okay. Maybe I can come to the class tomorrow.
Yeah, sure. Okay, take care. Bye bye.
Okay, bye. See you. Okay, now I'm going to show you example of a normal landline telephone that implemented Hart technologies.
Oh, it's Kali calling me. Hello, Kali.
Hi, Ram. How are you?
I'm good. How are you?
I'm good too. I want to see you about the project thing.
Yeah, sure. I'll send you my address. You please come to my house.
Okay, sure. I'll come there as soon as possible.
Okay, see you soon. Take care. Bye bye. Love you.
Okay, love you too. Bye.
Hi there. Now we are going to get to know about Hart protocol standards. I am Hart physical layer. What I do is uses my frequency shift keying to communicate.
Hi guys, today I will talk about Hart data link layer. It defined as a master-slave protocol, and timing rules define when each master may initiate communication transaction. That's all.
3.
Hi, I am network layer. What I do is provide routing, end-to-end security, and transport devices. Thank you.
Hi, I am Hart transport layer. What I do is I ensure communications are successfully propagated from one device to another. Hi, I am application layer. I define command, response, data type, and status reporting, which supported by the protocol.
Hey Kumar.
Hi Ram,
How are you?
I'm fine. How are you?
I'm good too. Hey, let's talk about hard devices.
Yeah, sure.
Sure.
Yeah.
Can you talk about it?
Yeah, sure.
Okay, then I will talk about advantages.
And I will talk about disadvantages.
Okay, let's discuss about it.
Yeah, come on.
About the advantages of hard devices. There's few advantages like gain early warnings to variants of process, device and products, and second, speed the troubleshooting time taken between identification and resolution. Not to be forgotten, Kumar, it increases asset productivity and system credibility. That's the list of advantages that I know. So let's hear from you.
Ram, that is very good experiment.
Reaction கொஞ்சம் மாத்து.
3.
Ram, that is very good explanation about the advantages. Very good one. But now let's hear about the disadvantages. One of the disadvantages is it is a very slow digital signal. And another one is only 16 Hart devices can be connected to a Hart multiple drop loops. So that is the disadvantages of this device.
There are two types of Hart configuration. First is point-to-point and second is multi-dot configuration.
I would like to explain you briefly about the point-to-point configuration. Okay, the traditional 4.2 milliampere signal is used to communicate one promises a variable, while additional process variable configuration parameter is transferred digitally using Hart protocol. Okay, the next is the Hart protocol provides up to 2 masses. One is primary and one is secondary. This allows a secondary master such as handheld communicator to be used without transferring without the primary master.
The second configuration is multi-dot configuration. The operation requires only a single pair of wire only, which all processes are transmitted by digitally. All field pooling addresses are less than 0 and the current through devices is fixed to a minimum typical current for 4 milliampere.
Information is transferred between Hart devices using commands. Each Hart command is identified by a number, and there are hundreds of different commands. Each Hart command is used to access a specific piece of information. For example, Hart command 1 provides the primary variable, typically the measured value, like temperature, pressure, level, or flow, of a Hart device. Hart commands are grouped into 3 major categories: universal commands that all Hart devices must support, common practice commands that are recommended, and device or manufacturer-specific commands that are, well, specific to a device type or a manufacturer. Hart is a master-slave protocol, which means that a field device, the slave, only provides data when it is requested by the host system, the master. The Hart protocol supports 2 masters, a primary and secondary. This allows secondary masters, such as handheld communicators, to be used without disrupting communications with the primary master, the host system. A typical installation with a Hart device connected to a host system is pull and response. The host requests a specific Hart command and the device responds with the information. There is also an optional burst communication mode that enables a single slave device to continuously broadcast a standard Hart message. Higher update rates are possible with this optional burst communication mode. The Hart protocol permits all digital communication with field devices in multi-drop network configurations of up to 15 devices. Each Hart device must have a unique polling address from 1 to 15 for proper operation. In multi-drop mode, the analog signal is not measured. The devices are configured to use a constant loop current, like 4 milliamps, only for power. All of the data is acquired using Hart. This is not a very common application because there's no analog control loop, but it is possible. Around 2007, wireless Hart was developed. It operates in the license-free 2.4 GHz band for global use. It features self-healing mesh network capabilities to ensure network stability and reliability, and has high-end encryption for data security. Even more recently, Hart has been adapted for use over Ethernet, the aptly named Hart IP. There are no special hardware requirements for Hart IP. Your standard switches, routers, and wireless LAN are all plug and play with Hart IP.
All of you guys understand the Hart? Thank you for your attention.